Johannesburg, and I would like to speak about developing a pilot biogas solar PV system for farming communities in Botswana. My presentation will consist in the introduction, just to give you a context of the research, objective of the research, the solar and biogas energy in Palapai, which is a town in Botswana used as a case study, methodology, conclusions, and recommendation for further studies, and then at the end, acknowledgement of some institutions that gave us the additional support. Of African people don't have access to electricity. One of the reasons is grid extension. Grid extension power transmission is costly and remains a challenge for geographically isolated areas. Large-scale projects require a lot of time, and they require also a lot of financial resources to become fully operational. The energy access in Africa is such that northern African countries have an average electrification rate of 90%, and accounts of the whole continent. The rest of sub-Saharan Africa, most of them have an electrification rate below 40%. In this case, Botswana is among the few that has an electrification rate of 40%. So this makes in our plans. As you can see, it is constituted of renewable energy and fossil fuel. However, fossil fuel such as coal, oil, and natural gas account the major part of energy sources in the continent. But it can also be seen that there is a lot of effort that is being deployed to develop technologies such as solar energy and hydroelectricity, of course, which is the point as well. Objective of the research. So the objective of the research is to identify a system that can reduce, improve, and that can be replicated to reduce polluting emissions with eco-friendly energy solutions. Of course, the peri-urban areas don't really have a proper waste management plan. So the other objective is to replicate in other disconnected rural areas of Africa this business model of a biogas solar PV scale with an installed capacity of 9 kilowatts. So we assume the 4 kilowatt peak for solar energy, and then 5 kilowatts biogas from biogas per unit. Solar and biogas energy in Palapai. So Botswana, Palapai is one of the towns of a country called Botswana. Botswana has an estimated population of 2.3 million, an installed capacity of 550 megawatts. As you can see, the main source of energy, 40%, 20%, 20% renewable. Today, country is estimated at 60%, among which 77% comes from, is 37. So Palapai itself is a very fast growing town, and is the fastest growing town in Africa. It has an estimated population of 82,386 people approximately, and the main economic activity are livestock agriculture and subsistence farming. The main source of energy is coal, and there is a lot of, the electrification rate is approximately 100%, because today there are a lot of neighboring coal power plants in Botswana. However, in Palapai, there are a lot of environmental challenges. The two of them, which are the main ones, are the carbon dioxide emissions from neighboring coal mines and power plants. And also, there is a lack of effective waste management. So what is the way forward? Is it solar energy? Is it the coal that is existing, the current existing source of energy? Is it wind power? Is it biogas? Is it an hybrid solution? What is it? According to a study conducted by Jacobson and DeLucci, 2011, it shows that the world can reach global energy access by 2030 if 1.7 trillion of renewable energy. They were encouraging 2.7 in the whole world will contribute drastically in order for us to reach global energy access by 2030. So let's first look at the solar energy potential in Palapai. Today, the solar energy potential in Palapai, as you can see, the global solar atlas that is shown here, that Palapai is in the eastern part of Botswana, and it has an estimated yearly solar PV potential of 73 and 1899 kilowatt hour kilowatt peak. Yeah. The biogas energy potential is also research. Some studies were conducted and proved that there is an average waste generation to be considered as a potential enough in Palapai, of course, to be considered as a potential town for this case study, as a case study. And also, Palapai is constituted of a very strong farming community. And which means that there is an availability of cattle manure that can also be used to generate biogas through anaerobic digestion. According to that study or those studies that were conducted, first of all, it was conducted in 3 types of households: low-income household, middle income, and high-income household. And according to the study that they've done, they showed that whether in low-income studies, middle income, or high-income households, food waste accounts that way. So, as you can see in these slides, whether on weekdays or on weekends, food waste accounted for the main amount of, or the abundant was abundantly generated from these households. We on weekends or on days. But of course, as you can see, weekend and also source of waste was the highest kind of waste that was obtained. High-income household, it was also the same reality. So the ability to associate the two technologies to obtain a solar and biogas hybrid system. So the methodology. Typically, energy profile of mono system, like in this case, it is a simple mono solar energy system. Assuming in a village where, let's say a village with an energy demand of 2 megawatts, okay, a peak demand. So as you can see, the solar energy itself, which is the technology that is developed, cannot meet the demand, the energy in the village at any time. So it is to supply just during a specific. It's much more easy because there is enough solar radiation, unless there is maybe climate challenges, but it is much more easier to supply during this time. And after, it is also a bit challenging. So this is why we, in this research, sought to hybridize solar energy, which is very adopted in the continent today, but with biogas, and especially in farming communities. Why? Because it manages interest of the solar energy source, it improves waste management system in the locality, it reduces polluting emission in rural areas, and then it is a replicable, affordable energy solution. So we are looking at this research to replicate, but at domestic scale, because biogas has always been most of the time used at industrial scales or much more larger scale. So how will it work? It will be constituted of 2 units. The first unit, there will be waste collection, there will be animal manure, there will be food waste generated by households, there will be animal manure from different farming, different farms, from kettles of different farms, and then abattoir waste. Because in that region as well, they have a lot of abattoir facilities. And then there is for solar energy generation, and then there will be a backup system. This is a pilot study, so we just to see the backup action and basically donating the food that people use and that people normally throw, and putting it in a digester, whereby it is there will be bacteria will digest, and then there will be gas that will be generated, and that will be used on the different form of energy for electricity, but that can also be used for cooking or for eating. And then the state that will remain here can be used for as a future biogas can produce power for 60% of content, only 6 kilowatt in the only 10 can be used for food purpose. So this is a facility. Solar energy production. This is basically, as I said previously, generating from the sun, but using, of course, different equipment such as inverters to convert the DC energy into AC. And this is at glance the hydropower system that we are thinking of proposing to communities such as the one of Palapai. As I said, instead of a solar power unit, and then backup system. An energy management system that can help one manage the power supply at the comfort of their home. And then this is the power supply projection that we are looking at. 12 hours with solar energy, 6 hours of biogas per unit, and then backup section will depend, of course, of the need and the availability of the system. This is the demand profile projection.
Jonathan, sorry for the interruption, but the time is out, so you can go to the conclusion, please.
Okay, I'm almost done. I'm done actually. There is only two slides left.
Okay.
So this is the demand profile projection. And the conclusion, as I said previously, is to manage emissions, improve the waste management, reduce polluting emissions, and get affordable energy solutions. This studies, our research show that 40% of waste generated in Palapai are food waste. 100 kilograms of food and animal manure abattoir waste could be used to generate enough biogas that can be in a solar system. So our recommendation is that hybridization of solar with other waste-to-energy technologies should be considered. We wish to thank the University of Johannesburg, the Botswana International University of Science and Technology, and the National Research Foundation. Thank you very much.
So thank you, Jonathan, for your presentation. I will ask to the audience if there are any questions, because we have just the time for a very quick question.